As I said before, we're in Chapter 3, using methods, classes, and objects. We're now going to talk about parameter list. So I mentioned before that I call the parentheses at the end of a method name the parameter list. And that's because it is here that we define parameters. Every method header contains a set of parentheses that follow the identifier. You can see the set of parentheses after main actually has a parameter inside. It's a string array. We're going to talk about arrays later on, but the main method has to include this string array, and that string array can be used when working with the main method. The display address parameter list has an empty set of parentheses. That means that no data can be brought into this method. A fully qualified identifier has a complete name that includes the class. When we add parameters to a method, there's two keywords we often use. The first one is the argument, and that's the actual data items you use in a call to a method. So it's the literal value you're passing in. For example, if a method takes in a name and I send in the value Chad, then that Chad is the argument, and the parameter is whatever the method header is defined as the name. Sometimes the method header will change a variable name. So I might have like username, and I might pass it into a method that has a different variable name. Realize that you're passing in the contents and not the name. And so the actual memory location may change names as you're using that parameter. In the implementation of this, we're allowed to encapsulate method details within a class. The calling method needs to understand only the interface to the called method. That is to say that I only need to know what I'm passing in. I don't care what the method is actually doing. And in this case, the interface is the part of the method which the client sees. So you're only seeing the parameter list, the data. You're hiding the implementation of the method. So when you're doing this, you need to define the access specifiers, the return type for the method name, the parameter type, and the local name for the parameter. That makes a complete method header. And it looks like this. We have the access identifier, which is public. It does not need an object, so it's static. It returns nothing, so it's void. And in this case, we're going to calculate gross, and it's going to have a parameter of double. That's the data type of double, and the identifier is hours. So let's look at this in code. Okay, so here we have our program. I have a class called pay calculations. I've saved that class. I'm going to go ahead and clear my screen over here in the terminal side. CLS will do that for you. Sometimes clear semicolon will work, but CLS is functional across the terminal world. And I can go ahead and compile this program, which is paycalculations.java. I can run the program. And what you'll see is this program ran 3 times. And let's talk about what exactly happened. Well, you can see I have 2 variables declared, hours, which is a double. I passed an int into the double, but it rebuilt that as a double. So it went ahead and put that into the broader primitive type. And then I did pass in a double as your hours worked, 37.5. And I went down to calculate gross, and I could call it 3 times. I could pass in an hour of 10. And when I passed in 10, it did its business. It took the standard rate. We declared a variable called gross. We multiplied the hours we passed in by the standard rate, and we printed that out. And you can see 10 times 13.75 is $137.50. And then we went in hours and we passed that in, and it says $25 an hour is $342.75. And finally it said 37 and a half hours is $515.62 and a half cents. I want to show you guys something interesting real quick, just so you guys can see this. There is another function of Java that we can use called printf. And I think you might like this a little bit. I'm going to go ahead and re-type in, let's see, hours. Let's go ahead and make that an F. Let's say 0.2F. And I'll talk about what's happening here in a second. And by the way, this is not required. I don't think this is covered in the material, at least not at this point. Let's see, $.2F. Okay, and what we're gonna do here, this is gonna be a string, and I can pass in percentage, .2F. I can pass in now the hours, the standard rate, and the gross. Let me make sure I did this right. I got the hours, I got the standard rate. So basically these percentage and printf, this percentage F is calling in a float. And then the 0.2 is giving us 2 decimal places for each one of those floats. So this is a ability to have like a variable that brings in the data, and I can pass in the variables in that way as well. And I'm going to go ahead and save this, and if I did this right, it should work without any problems. What did I do wrong? I forgot to put a comma. This is a parameter list, so I'm going to put a comma here. I'm going to go ahead and save this again. I'm going to clear my screen, and I can do this again. And let's see. You can see that. What did I do? Okay. 375. Oh, I know what we need to do. Okay, I'm going to go and put a new line at the end, which I can do with percentage n. Let me save this and run it one more time. And I think it'll make more sense. Alright, and I can show what I was trying to show you earlier. Sorry about the weirdness here. Let's see. Okay, there we go. Alright, now what I like about the printf function is that it goes ahead and rounds, because I told it to put it in 2 decimal places with the 0.2, and it rounds the value. So now you can say 37.5 hours at 13.75 per hour is $515.63. And allows you to fit it in without all the plus signs, which sometimes get confusing. In this case, you might want to make this 0.1. And if you make that 0.1, it's going to make 1 decimal place. And I'll show you that as well. You can see how that pulled that down to 1 decimal place. But this to me is cleaner, and some of the code is cleaner. But you don't have to use that if you don't want to. We're going to go and comment that out for now. And just talk about the fact that this method call, this calculate gross, can be called in these different ways, and the same method is run. This concept of modularizing things to use this way is called abstraction. We've abstracted calculate hours from the long equation in the print command to a simple call to calculate gross. And what's important to know is that when we have a variable within a method, that variable is known only while the method is open and running. But once the method stops running, that variable is cleared from memory. Each time the variable executes, the variable is redeclared, and a new memory location large enough to hold the data type is set up and named. You can see in our program that we called calculate gross 3 different times. Each time the method was called, the parameter hours received a copy of the value that was passed, was used in the program, and then when the program stopped running, it basically collected that. The garbage collector picked it up and destroyed it. When we called it again, hours was recreated, and it ran the program that way. Effectively, hours received a copy of the argument, the value that was passed each time. The first argument was 10, the second argument was 25, and the third argument was 37.5. You can also call methods that have more than one parameter. I want to move myself here. When you have more than one parameter, you list the arguments within the call to the method. Then you call the method. The arguments that you pass to the method must match the parameters listed in the method declaration by number and by type. The method signature must include the method name, the number, types, and order of the arguments. And this is how that looks. Let's see. You can see in this case, you have multiple parameters you can pass in to calculate gross now. You have hours and rate. The parameters are separated with a comma, and each parameter requires a data type and an identifier. So let's jump back into our code and look at that. So now, instead of having hours, just hours, we can have double and rate. Now in this case, we no longer need the standard rate here, right? And our hours will now be multiplied by rate. Once we've done that, let me go ahead and take out the standard rate and call this rate, right? I'm gonna take away this printf command just because, I mean, that was just for fun last time. All right, so we have hours at rate, and up here, we can pass in a rate. So I can say, calculate gross at $25 an hour, calculate gross at $13.75 an hour, calculate gross at 15.80 an hour, right? That's because now I need both parameters. I need two doubles to pass in here to run it, right? I'm gonna go ahead and save this again. I'm gonna clear the screen and I'm gonna run our program, right? So I have Java C pay calculations and Java pay calculations, and you can see now that 10 hours at $25 an hour is $250. 25 hours at $13.75 an hour is $343.75, and 37 hours at 37 and a half hours at $15.80 an hour is $592.50. And so this is how to have two parameters in a single method. We're going to stop the recording here.